Hello everyone, I am Jack and I'm back, and let me show you what I've been working on. If you've been keeping up, these are my carbon fiber hood vents. They are finally finished, and let me show you what I got. So each of those vents themselves, the slats, were made individually out of a sheet of carbon fiber. Actually, what I did was I put down a sheet of foam board. You can see I've got foam board, black foam board over there. I use black so that the background would not show through with the carbon fiber. I tried white once and you could still see in between the weave of the carbon fiber in some places. So by starting with black, it resolved that issue. That also gave me a thickness, so I did that. And then I put a layer of carbon fiber with epoxy on each side of the part. Now I did the whole sheet and then I cut out the vents from that using a vibrating cutter. Each one of those is its own shape and customized for the specific application. Then I needed to mount the vents. And then to do that, of course, I made a mounting system. So if you look, this right here has a mounting system that mounts the front of one and the back of another. I initially put slots, but it was very tedious and time consuming to make the slots the exact width that I wanted and all that. And then I said, wait a minute, I don't need to do that. I just need the angle and the position, so I can do that by attaching every other one. Now in the future, I'm going to go ahead and do slots, but I'm going to digitize this and duplicate it that way. That way I'm not doing so much hand manipulation. It took a lot of hand manipulation and massaging to make these things. Now the bracket part, or the stand part itself, I made it using bed liner. And the reason I did that was, one, you could see it from the top and I didn't want it to be visible, noticeable. The end brackets there are aluminum, and so you saw this bright aluminum thing inside of the hood vent, and I didn't want it that look. So I needed to make it black, and I decided to use, that was a personal decision, deciding to use the bed liner. Could have used flat black paint, could have used other stuff, but anyway, I decided on the bed liner. Reason why is whatever I do here has to be weatherproof. And so obviously bed liner, you can't get much more weatherproof than that, and sun resistant from dulling. All right, and then I used bolts right here to hold this together. So each of these vent assemblies is standalone. These brackets right here are simply the adapters to go from this standalone vent to give it something to mount to on the hoods. All right, let's see. Okay, so once I did that, then I took the pieces and I took a picture of the vents. This was before I assembled everything. So each of the vents, there's each of the 5 vents. Stood above the vents, put them on. Oh, that's a table there with a bunch of stuff on it. Anyway, put it on the table and then took a picture of it. Now, if I zoom in here, you'll notice that this one right here is where the camera was straight above. And then, of course, as you go along, you can start to see the side of it because that's a limitation of the camera. Could have taken a picture of each one individually, but this isn't rocket science. I just needed the basic shape of these. So then once I did that, I loaded this. This is Fusion 360. I loaded it into Fusion 360. And if you look, there's a thing called Canvas option. And so I loaded that picture into this as a canvas. There's the actual image. If I make this go away, you can see that there is just the surface by itself. So I loaded this into the canvas, made it into a top view. Now there are different views. I can move this around and you can see the different views. Now this, because it is the canvas, it does not have a 3-dimensional shape to it. It looks like it because of that shadow or the edge right there, but it isn't. It's just a picture. So then what I did was, let's see, I created a sketch. So if I go off and turn on the sketch layer, you can see the dots here. I made a sketch of each one. All I cared about was the outline itself. So each of those has a sketch outline. All right, and then once I did that, then I created bodies out of those by extruding those. So if I turn on the bodies, you can see that there is an extrusion. Now again, in the sketch, that was only two-dimensional. Let me get rid of the bodies real quick so you can see. There's the sketches. If I go and move this around, you can see it has no thickness. You can see the dots, but it has no thickness to it. All right, so let's go back to the top right here. Now, if I turn on the bodies, make them visual, now, as I go, you can see they have a thickness. All right, and the same thing over here. If I go this way, there's a thickness to it right there. All right. And then I can go back home, and it is a orthographic view. So there's all 5 of those vents. So then what I did was I said, okay, I got the shape. Now I want to make those parts. So there's several different options on how to do that. Ultimately, I'm going to use a laser because it's a flat piece and it could be it's two-dimensional. From the top, I could do a DXF file, have a laser cut it out. I've never used a laser in my life, so that's going to be a learning experience. So I just needed the files. But what I can do here is I do have my mill, 5-axis mill, and the Mach 3 software. So what I need to do is, and I want to learn how to do 5-axis milling. Well, there's no reason to use 5-axis milling, and it's actually a $2,000 option to upgrade this to do 5-axis mill. You can do 3+2, which I'll look at, but I decided, okay, I'm going to go ahead and mill these out. So right now I'm in the design system, whatever you want to call it. So if I drop this down, there is a manufacture system. This allows me to actually create the files to manufacture this. So then what I had to do was I come in here and let's see, I had to create a program and a setup. So if I come up here and I go into the setup option, let's see if there we go. All right, so the setup is where I go off and literally set it up on what I'm going to do. Let's see, is there an edit? That's what I was looking for, was an edit for it, but I don't see it. So let's go to this setup, the specific setup, click on it, and go to edit. There we go. All right, so if I come over here in the setup, the first tab is the setup. What machine am I going to use? Well, in this case, I use the Mach 3 mill. There is a long list of machines you can use, and this happens to be the one that I am using. This is not based on my machine. It is based on the software, but they do have ones that are based on the specific mill you're going to use. It's just my mill's a handmade mill, so it doesn't exist, but the software does exist. So what this will do is this will create the G-code that gets fed into the Mach 3 mill software. And then that software, it's up to the configuration between the software and the machine, how that works. Completely different thing. All right, operation type, I'm going to mill. Let's see, I could do turning, cutting, additive, whatever. Cutting, I'm guessing, would be just 2D. But I'm going to do 3D because, again, I know in the future I'm going to need 3D, and it's just extra here, but it doesn't hurt anything. All right, there's my orientation, the stock that I'm using, where my stock point is. In other words, when you load the thing, what's the model, cam. And then I left all of this alone because it is actually specific to my setup of the machine, and my machine isn't even working yet. It's close, but it's not working yet. All right, so I left most of those at the default. Stock, relative positioning. The nice thing about Fusion 360 is you go to any one of these items and there's a flyout that tells you exactly what is happening there. So you can go through and customize each one. Stock offset. Do I want some offset from the stock? Side, top, all of that. And then the stock dimensions. And again, I just left the defaults. All right. Part position. So where is the part relative to the mill? Now, this is part of my confusion. I have absolutely no clue what in the world this thing is supposed to be here. Let me go ahead and go to the top, go to this side. There we are. And let's rotate it. Ching, ching, ching. So for some reason, it thinks there is a 5-axis maker something. I don't know. So I'm just going to ignore it. I think that might have been because at one time I told it I had a 5-axis machine, and then I went in and went, well, I don't want to. Oh, and to do 5-axis, you have to pay for the $2,000 upgrade. So it stopped whenever I tried to do anything and said, oh, you need the upgrade. I said, no, I don't want it. So I removed it, but apparently there's some ghost of it here with this. Luckily, it doesn't impact anything, but this is how I'm going to position my part relative to the mill. All right, and let's see the next thing. Oh, that's where I'm at. And then finally, post-process. Now, the post-process is where it takes the toolpath of this and then converts it into G-code that will work with the Mach 3 mill. So that's specific to each mill. Okay, so I'm gonna cancel this because I don't want to change anything, but this is what I've got. All right, so I have this set up. I went in and created, you can see there it says my Mach 3 mill. And then this is my tool path. You have to create a tool path. So I come in here and look at this. And in that, I tell it what kind of mill I'm using. And then that just tells me how big the file is. But if I come in here, right click on this, and I bet you there's an edit. Yep, there's an edit at the top. All right, so if I come over here, here's this. So I already told it use this tool, and there's a drop down. You can tell it there's a whole library that you can use. So I just picked a library tool from it. All right, I just used a flat end mill because that'll do this. In most cases, I would use a ball end mill because I'm doing something three-dimensional and contoured. But you can go in here and you can set all of these. Again, I just left the default. All right, the next thing, multi-axis. This is where I had messed up previously and told it I wanted to do a 5-axis, and I don't want to do a 5-axis. All right, next is geometry. There it shows the shape that I'm dealing with of the 5 different vents. Machining boundary. Again, I left all of these at default. Okay, next thing, heights. What kind of height does it have? If you go here, it'll show you the boundary of what it's machining. You can see the boundaries above my part. The blue is my part, and the red is the boundary. So it creates a boundary around everything because typically you got to clamp it, and so you need some space outside of where you're at. So I went ahead and, again, left the defaults. Fine with me. All right, number of passes. It tells what kind of tolerance I have for my machine, what the optimal load is. The optimal load is you don't want to go too hard when you're cutting because it'll break the end mill. And this is a thin end mill that it's using, so it's a relatively small. They give you numbers there to use. Okay, let's see. And then the last one is linking. I've never even used the linking. I have no clue what it's for. Okay, so That's what it took to get this to work. I did want to bring up another point that you can see I put a scale here, tape measure. What it is I could come in here and look at it and go, oh, this vent is exactly blah, blah, blah size. Okay, it's a little over a foot. But I don't need to do that. When I scaled this, when I brought this picture in, it just needed a scale. So what did I do? Well, I went from the end of this scale to there, to the 1 foot mark, and said, that's 12 inches. So it doesn't matter what I scale here. I could have gone in here and went, you know, a 1 inch scale or 5 or 6 or whatever I wanted. This is a lot easier than trying to measure exactly from this corner to this corner or this edge to that edge on the part and then transfer that to here. So by putting a scale in the picture, I have a absolute scale. In fact, a steel scale or something like that would actually be better than the tape measure because of the little bit of inaccuracy right there. Not a big deal, but I saw that tip and I went, hey, you know what? That's exactly right. I just need something to give the program an idea of scale. All right, so I've done all this, cancel this, and there is my tooling path that it's created. So now I can come in here and click on, I think it's this one. Simulate, there we go. All right, so now I can come in here and simulate machining of this thing. So let me go back to, there we are. So there is the end of the spindle and the end mill. And then there is a part right here that has a, you can speed it up, slow it down, go forward, backwards, whatever you want to do. So I'm going to go all the way to the beginning and that should have started. All right, so I slowed it down too much. This is the speed. So let me come up here, speed it up. There we go. Now this is obviously way faster than it would actually cut, but this just gives you an idea of, sure enough, I've got the program, I got the tools, I got everything I need. And let me get rid of this. This is what it would do if I was actually going to use the mill to machine this. So it would come in here and do all this. Obviously it would be a whole lot slower. If I slow it down, you can see that. Maybe that's too slow. There we go. So there's an idea of what it would do if I was going to machine this. It's kind of silly because there's no reason to cut. I could actually just do a perimeter, but this assumes that for some reason I actually want this exact shape and want this part here to remain, which of course I wouldn't want. But the idea is, you know what? I've got a program. Okay, so then you come in here and I actually created a NC program. And what this is this is what allows it to create the output for my specific mill. All right, so let me go ahead and exit the simulation. I will minimize this and I will show you that. So if I come over here and, oh, I don't see my Mach 3 anymore. Oh, crud. I had it running so we could show. Some of the other things I wanted to show before we do that is I needed the stand and I did it a little bit differently. I found a tool that you can go off and take a picture and it'll make a 3D model. So I did that, plugged it in, and then I had to do a lot of manipulation, afterwards file manipulation to clean it up, because anytime you do a scan, it's basically what I call a dirty scan and you have to clean it up. And it's a whole bunch of points. And so you got to convert it to where it's something else. This is a step file, which a lot of software requires when you're going from just a visual model to an actual 3D machine model. All right, so I have a step file right here. And if I come down here, you can see, all right. So I also used FreeCAD and put it in here. And this is how I created the DXF file. So this is just the 2-dimensional file that would allow me to cut this out. That's another option. If you don't have Fusion 360, you can use FreeCAD. Again, just pick your poison, it'll work. But you can see that there's my part right there. And I can come over here. I thought I could. There we go. And you can see it's exactly the same as what I've got in Fusion 360. Okay, but they're step files. Sometimes their step files are required. Different file formats are required. So if I come over here, you can see that there's my FreeCAD files. Again, that's what I use to create the step files. There are the file formats for FreeCAD specifically. And then here are the DXF files. Let's see, do I have the DXF viewer up? Well, of course not. I thought I did. So let's just double click that. And we'll wait for that to launch. There we go. And there is the DXF file. Now, if you're familiar with DXF, it's just a two-dimensional outline. So this is what I probably am going to use with the laser. But again, I'm not familiar with the laser. I'm assuming that's the case. I'll know in the next week or two. I'll have access to the laser. I've got to get, it's at the, let's see, the Denton Maker Center. They're not calling themselves a maker space, they're calling it a maker center. So I just reached out to them and said, hey, I've got some things. What I'm going to do is I'm going to do all of this in wood and verify it before I send it off and have it actually machined. Okay, and I just want to make sure there's no errors. All right, so then I come over here and there we go. There is the Mach 3 mill. And what I'm doing here is I'm simulating in here. And if you look, it is working on cutting out right now this vent right here. Very slow, very tedious. Hopefully in real life it won't be so slow, but even if it is, it's not a big deal. I would just put it in there. But again, this is not the way I plan to do it, but I just wanted to make sure that, hey, I can create a part in Fusion 360, export it, generate the G-code, load the G-code into Mach 3, and then once I get the mill going, I could actually machine these parts if I wanted to. Okay, that's the whole process. One other thing I wanted to show, if I can find them, I don't know what I did with them. Let's see, I've got a stand. Oh, it's in a browser. It's on an online thing, so let me see, there it is. Okay, so this is the stand that we saw. Let me go ahead and make this full screen right there. Now what I did was I took that and used a tool that would convert it into a 3D shape. You can see that doesn't show the bolts and all that. And in fact, it had a solid floor on the bottom. So I took it into another tool, cut the floor out, and you can see this. What I need is these pieces right here. So it filled in a lot of stuff that shouldn't have been filled in. Doesn't matter, I just needed the basic shape. What I'll have to do here is actually go off and measure the distances and then scale this appropriately. I will assume it is not scaled right now. So let me go ahead and get the part. Oh, the other thing I wanted to show is, if you look, my stands are the same. The basic design is the same, except that the distance, in other words, this one's got a long arm here and then a shorter distance across here. That one's got a short arm there and then a wider spacing across there. But the pieces are the same, especially the mounting brackets. So I have a generic mounting bracket here, and I just adjust the dimensions to mount it depending on whether I'm doing a long and thin vent or a short and fat vent. So if we get back here and look, this right here is what you're looking at on the screen. Okay, and then this piece on the end that has a bolt is a separate piece. That's what I need to duplicate somewhere. All the rest of the stuff can be cut out of flat stock. That can't. I needed that 90-degree bend there to allow this to bolt to the surface because the surface is 90 degrees. So what I will have to do at some future date is come in here and separate those. So in other words, there's my angled piece right there. So at some point in the future, I will need to separate that. Let me again see that it took a little bit of, see it filled in that area right there. I can't do both, but anyway, it's not exactly like this. It's similar, but it's not exact. So I will have to come in and trim this up, but at least I've got the basic shape, which I needed. The other thing is it's not 100% accurate. If you look at this and we zoom in, you can see that that thing is absolutely flat on the actual part. It isn't so rounded as it makes here. But again, it gets the general idea. So what I will do is I will do exactly like I did with the other piece, the vents, is I will load this into the software Fusion 360. Then I will trace the outlines. I'll straighten up all of these edges. And this would be the same distance across here. And then what I'll do is I'll come in here and create a filler piece right through here so that that is a slot. And then the width of that slot will be the thickness of each of the vents, which is what I wanted to do, but it was time consuming and tedious. I was hand filing those slots on the first version of this, and it just took way too much time. So I realized, wait a minute, I don't need to do that. I can do like I did and glue this vent here, glue that vent there, glue this vent here, glue that vent there, blah, 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 and end up with the same end result. All right, that's what I've got. Just wanted to show you what it took to get from hand making these vents to then taking pictures of them and then digitizing those pictures and then making it into actual 3D files. Now, it was easier to make them into STL files, but the online places that I am having the machining done, some of them don't take STL, so the STLs wouldn't work. So then that's why I had to go in and create the actual 3D files as step files, because they did take step files. Losing my voice here. All right, so let me go ahead and, what happens when I do that? There we go. Okay, so that's what I've got. That's what I had to go through to get all of this to this point. I still have more to do. I have to get all of this done because these are sold. And so I don't want to have to go through all of the redesign and all that effort. So before I ship these off, I want to get the digital files all done and ideally cut them out with the laser. But even if I don't cut them out with laser, I want to be very confident that I've got everything I need, dimensions and pictures and files and all that stuff, so that I don't have to duplicate all that work. That's where all the work went. Oh, the other work was hand finishing these, getting these vents so that the part is all glossy like I wanted. It was surprisingly difficult. The thing about carbon fiber is it is not sun resistant, UV resistant. So you have to coat the parts with a clear coat that has a UV protectant in it. That took a lot of time because it kept having issues where there were fish eyes or solvent pop or whatever. I don't know exactly what it was, but I kept running into the surface was less than perfect. So I'd have to sand it down, spray it again, clean it, all of that stuff. And it just took a lot of work to do that. So there's a lot of time involved in this. I'm hoping on the ones that I have machined, I can actually specify that I want them clear coated. If not, I'll just send it to a paint shop and have them clear coated. All right, that's what I got. So like, subscribe, hit the alert, hit the things if you want to donate. And if you don't like what I'm doing, you don't know jack. Bye.